Hello, this is your completing the square video. So the do now starts by asking you to find the value of c such that each expression is a perfect square trinomial. So we have to think back to what a perfect square trinomial means. And the perfect square trinomial is the answer that you get when you square a binomial. So I'm going to think back to what number would be here. So basically, I'm going to take this 18 and I'm going to divide it by 2. That gives me 9. So that means that before the multiplication occurred, it was x plus 9 squared. So therefore, after the multiplication occurred, it was 9 squared for that c, which would be 81. So c would equal 9 squared, which is 81. Okay, so I'm kind of working backwards towards what that trinomial was. So I'm going to take the 22, I'm going to cut it in half, and that's going to give me the 11. And that tells me that before this was multiplied, that was x plus 11 squared. Therefore, c is equal to 11 squared, which is 121. Okay, the other thing to keep in mind is that c is always positive. Okay. So negative 30 divided by 2 is negative 15. Negative 15 squared is equal to 225. Okay, negative 10 divided by 2 is negative 5. So c is equal to negative 5 squared, which is 25. Okay. Negative 8 divided by 2 is equal to negative 4. So c is equal to negative 4 squared, which is equal to 16. C is always positive. Okay. What's in the parentheses for the multiplication question, that sign will always carry through. So since that 4 is negative, that's going to be x subtract 4. Okay, and you can always use your calculator. I'm not sure why so many of you don't, but this calculator checks all of this. So you can take x minus 4 squared and make sure that you do indeed get x squared minus 8x plus 16. I would really suggest you start checking your work. Okay, so the approach that we're taking to solving a quadratic equation is a special approach called completing the square. And basically, completing the square comes from the idea that you have a perfect square trinomial. So we want there to be a perfect square trinomial. So what we're going to do is we're going to force the equation to contain a perfect square trinomial. Okay? So the first thing, prior knowledge-wise, that you have to know is what is a perfect square trinomial. So again, the perfect square trinomial is the result that you get from squaring a binomial. So if I look at the first line, x squared minus 6x plus 9, that is a perfect square trinomial. It's the result of squaring x minus 3. So what I want to do is I want to have a perfect square trinomial equal to any number. It really doesn't matter what the number on the other side is at this moment. You are going to use that number, but like that number doesn't have to be something specific. Okay? So basically what I do is I set up the perfect square trinomial, and then I factor the perfect square trinomial. So once I get to here, this is the factored form. And basically, I'm going to undo the square. So the opposite of squaring is square root. So when you do this square root, you cancel out that square. It's like square gone. Okay? And then because this thing is an equation, whatever you do to one side, you do to the other. Okay? Now, what's a little tricky is that we're so very used to saying the square root of 25 is 5. And that's a fact. It'll always be a fact. But we want the principal square root, which is the positive one, and the negative square root. We want both square roots. Okay, and that's something we really haven't done before. So when we take the square root of 25, we have to remember that negative 5 squared is 25, and so is 5 squared. Okay, and then you're just going to solve this new equation here. You got to solve that. And you just solve that by the opposite of subtracting is adding. This method is called completing the square. Super cool, super fun. Gotta know how to do it. Okay, so here we go. I'm going to force the left side of the equation to contain a perfect square trinomial. So I'm going to keep this x squared. I'm going to keep this 10x, but I'm going to move this 15 to the other side. In order to do that, I do the opposite of adding, which is subtracting. So that's going to give me equals negative 15. All right? So you'll notice that I left this blank space there. I left that blank space there on purpose because currently on the left side of the equation, there's a binomial. A binomial cannot be a perfect square trinomial. So what I need to do is create this perfect square trinomial. In order to do that, I'm going to take the 10 divided by 2. That gives me 5. I'm going to take the 5. I'm going to square it, which becomes 25. So I'm going to put the 25 there. But remember, this is an equation. So whatever you do to one side, you do to the other. So because I added 25 there, I have to add 25 there. That's called the property of equality. It's keeping the fact that it's an equation true. Okay? So now I'm going to factored form. This is factored form. And 25 minus 15 is 10. Okay, that's called factored form. After I get factored form, I'm going to take the square root of both sides. And that's going to give me x plus 5 equals plus or minus the square root of 10. All right, square root of 10, irrational. So I can't simplify this into a rational number because it's not one. So it's actually like a leave it alone kind of thing. Just leave the square root of 10 there. Okay, the opposite of adding is subtracting. So I get x equals negative 5 plus or minus the square root of 10. That is an answer. It's an irrational answer, and that's fine. Not all answers are rational. Not all numbers are rational. That's why we have rational and irrational. All right, let me go through this again. This page completely just notes. I typed everything I just said. Read this, take your time, okay? All right, so I'm going to do 2 more with you, and then you really just got to do it by yourself. All right? Okay, so I'm going to start with the x squared minus 2x, and I'm going to move the negative 3 to the other side. The opposite of subtracting is adding. Now, I'm looking for the number that would go next to the subtraction 2x to make that left side a perfect square trinomial. So I'm going to do negative 2 divided by 2 equals negative 1. Negative 1 squared equals 1. So I'm putting a plus 1. Whatever you do to one side, you do to the other. That's what keeps the equation true. Okay, now I'm going to factored form. So I'm going to factor this into x minus 1 squared. 3 plus 1 is 4. Now that I have a square, I'm going to do the opposite of squaring, which is square root. Whatever you do to one side, you do to the other. That gives me x minus 1 equals plus or minus 2. The square root of 4 is 2. The square root of 4 is rational, so I'm going to get an integer answer. Okay? Now I'm going to solve the equation by doing the opposite of subtracting is adding. And this might look a little weird. It's 1 plus or minus 2. Okay, 1 plus 2. Oh, that looks really bad. Hold on. Isn't that the eraser emoji? Yes, it is. Why aren't you erasing? Eraser. Not sure. No, I don't want to erase everything. I just want to erase this. I guess it's not going to let me erase, so I'm not going to get stuck here because I'll spend 10 minutes. Oh, wait, eraser. No, still not working. Okay, so I'm going back to the pen. No, go back. I don't want to clear the screen. Oh, can I erase now? No, it's not letting me erase. Great. I don't know how to get rid of that, and I just want to keep going. So anyway, it's going to be 1 plus 2 is 3, and also 1 minus 2 is negative 1. Okay, so here we go again. So I want to make this a perfect square trinomial. Half of 4 is 2. 2 squared is 4. So I'm adding 4 to both sides. I want to make that a perfect square trinomial. Okay, perfect square trinomial. Then I factor this. 16 plus 4 is 20. Then I take the square root of both sides. I get x plus 2 equals plus or minus the square root of 20. The square root of 20 is irrational, so I'm leaving it like that. So then the opposite of adding is subtracting. So I get x equals negative 2 plus or minus the square root of 20. That's an irrational answer. I'm going to leave it like that. We can talk another time about simplifying radicals and all that good stuff. All right? Please, please, please do your work.